In today's sequences and series lesson, we are focusing on the sum to infinity of a geometric series. Let's consider this series. We can see here that this is a geometric series because there's a constant ratio of 2. If we now go and calculate the sum of the first term will be 1. If we now add the second term, it will be 3. If we continue by adding the third term, we'll get 7. And this sum will continue getting bigger and bigger as we go. Mathematically, we say that as n tends to infinity, or as we keep on adding terms, then the sum will also tend to infinity, or the sum will keep getting bigger and bigger. And this type of series we call a diverging series. So this series will diverge. Now let's have a look at another series. This is also a geometric series, but this time the constant ratio is a half. Once again, if we start with our first term, the sum is 1. Then we add a half, so it becomes 1.5. Then we only add a quarter. And then as we keep adding, the value we add gets smaller and smaller because we multiply by a half. And this will continue up to such a small value that adding that value won't even really make a difference in the total sum. So as n tends to infinity, as we keep adding and adding, in this case, the sum will tend to a specific value of 2. That sum gets closer and closer to 2. A series that gets closer and closer to a specific constant value as we keep adding is called a converging series. So in this case, this series will converge. If we now compare these two series, we can say that as soon as the constant ratio is a value that makes the next term bigger and bigger, the series will always diverge. But if that constant ratio is a value that makes the term smaller and smaller, then the series will converge. That means that it will converge if the constant ratio is between -1 and 1. And this is the type of series that we are going to focus on in this lesson. There's a formula that we can use to calculate the sum to infinity, and that is a divided by 1 minus r. So let's have a look at an example of how we use this. Example 1. Calculate the sum to infinity of the following geometric series. In the series, we know that a, the first term, is 2, and we can go and calculate the constant ratio by dividing term 2 by term 1, and that will give us a constant ratio of -2/3. Now we can go and substitute that into our formula. So this will be 2 divided by 1 minus the constant ratio, and that is 6/5, or if you want to write it as a decimal, 1,2. So this means if we keep adding and adding to this series, the total sum will be 1,2. We can now also use this formula to convert decimal fractions to normal or common fractions. Let's have a look. Example 2. Convert the following recurring decimal into a common fraction by first writing it as an infinite series. So we know that 0,3 recurring is actually 0,3333, and it continues like that. So if we want to write this as a number pattern, we're going to start with 0,3. Then we're going to add 0,03, and now we have the first two decimals. And we're going to continue by adding 0,003 and continue like that. Here you now need to see that a in this series is 0,3, and my constant ratio is term 2 divided by term 1, which is then 0,1. And now we can go and substitute that into our sum to infinity formula. Substitute a is 0,3 and r is 0,1, and that will give us a final answer of 1/3. 3. So this means that we can rewrite 0,3 recurring as a common fraction of a third. Let's have a look at an example where there is an abstract series. Consider the following series. They now ask us for which values of x will this series converge. Now we already know that for a series to converge, the constant ratio has to be between -1 and 1. We know that the constant ratio you calculate by dividing term 2, 3x times x minus 2, by term 1. And this can be simplified to x minus 2. So now we know the constant ratio, and we know this constant ratio has to be between -1 and 1, which means that x minus 2 has to be between -1 and 1. Now, to solve x, we are going to add 2 on both sides, which will give us 1 and 3. And this means that any x value between 1 and 3 will make this a converging series. In B, they now ask us, if this series is converging, calculate the sum to infinity in terms of x. So now we substitute into our sum to infinity formula. We know that the first term is 3x, and we know the constant ratio is x minus 2. So if you simplify, it is 3x divided by 1 minus x plus 2. So that is 3x divided by 3 minus x.